Okay, I'm going to quickly go over the free response homework for chapter 6. So a few people have asked for this. Just so you know, if you hear any rumbling, there's a little bit of thunder, so that's probably why. I'm going to just quickly go through this. I think it's just about 2 main questions. So I'll go through this and hopefully that will be helpful to you. So using the following substrate, name the substrate indicating R or S configuration. So first I'm going to find the parent chain, 1, 2, 3, 4, 5, 6. We could start from the left or the right. I'm going to count 1, 2, 3. Either way, your alkene is at 3. It's the highest priority, so it needs to have the lowest number possible, but it's 3 either way. So we're going to start from this side to get the chlorines lowered numbered. So hexane is your parent chain. We have 3-ene as a substituent and 2-chloro as a substituent. So that would be 2-chloro hex 3-ene. And then we have to say if it's R or S. So I'm going to assign the highest priority to chlorine. The hydrogen's the lowest priority. It's already pointing back, so that's great. This would be priority 2, and this would be 3. So 1, 2, 3. So that goes to the right. So that's our clockwise. So that's our configuration. So R 2-chlorohex 3-ene. Is that right? Yeah. Okay. So now suggest a nucleophile that would favor an SN2. I'm going to favor a narrow nucleophile that's negatively charged. So I'm going to do ethoxide. This would also be written as this, or any of those would be the same thing. So now I'm going to draw the mechanism. I'm going to redraw the the starting material. And then I'll have this come in, and it's going to attack from the back and kick out, and we will get now the nucleophile attacked from the back side. So the implied hydrogen is on the front, and the leaving group is left. So we also get Cl minus. And to draw the transition state, I actually like to draw the transition state where we have the we have the chlorine leaving, the oxygen starting, and then the hydrogen is still there. And I sort of draw the hydrogen in the plane of the page and then have, oh, sorry, I didn't mean to write right there, but the hydrogen in the plane of the page and then the chlorine going out one way and the oxygen the other. So the leaving group leaving and the nucleophile attacking, and so that's the transition state. And the name of the product would then be S. Oh, well, we haven't learned how to name ethers yet, so that's a bad question. If I had done alcohol instead, so let's pretend I did alcohol instead and I used OH minus, that would be easier to name because it would be S, let's see, hexane, 3-ene, and 2-all. So this would be S hex 3-ene 2-all would be the name. It's kind of a tricky question I gave you. Okay, and then on the back of this question, suggest a nucleophile that would favor an SN1 reaction with that same starting material. So I'm going to just redraw our starting material so we need to remember what it looks like. So I'm just going to do water as my nucleophile. So this is weak, and so that's why it would favor, and it's narrow, so it would favor SN1. And then it'll still give us an alcohol, so we can name it more easily. Okay, so the first step is the leaving group leaves. So that leaves us with a positive charge here, and that's actually stabilized by resonance, so but it won't undergo rearrangement. There's no more stable place for it to switch to. And then our nucleophile would attack. And you would get your alcohol that's protonated. And this is going to attack from both positions. So you're going to get this plus the enantiomer. you'll get the wedge and the dash of this, and then it'll deprotonate. So probably the water will come and take that hydrogen and leave these electrons behind, and you get OH plus the enantiomer. So it's the same name as what we had last time, but you'd get R hex 3-ene 2-all and S hex 3-ene, nope, lose the E, 2-all. So those would be the name for that. Okay, the next question is, for each of these, predict SN1 or SN2. You consider the strong nucleophile and the nature of the substrate. Then, using curved arrows to show the flow of electrons, predict the product. I didn't include solvent here to avoid confusion, but often solvent will be included because molecules have to be dissolved in something. But for the free response, I more was worried about you being able to understand the mechanism. So I'm just going to start by going through and labeling this as weak, strong, 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 and weak. And so this would favor SN1, this would favor SN2, this would favor SN2, this would favor SN2, and this would favor SN1. But now you can't just consider the nucleophile, you also have to consider the substrate. So SN1 with a secondary substrate, that's possible to get that carbocation. So I think that would go by SN1. The leaving group would leave. We would get this carbocation. It doesn't undergo rearrangement because there's no more stable place to go. And we get our ethanol. This is positively charged. And then the deprotonation step leaves us with this ether. This NOH for strong secondary nucleophile. So secondary leaving group, would also give us an SN2. So this OH minus would attack and kick out that leaving group. Oh, I didn't include stereochemistry here. Sorry, I should. This will give you this plus the enantiomer. So the wedge and the dash would both be formed, but this only the dash would be formed. So that would be the product for that one. This is strong, so it favors SN2, but our leaving group is tertiary, so that cannot undergo SN2. So if you've already learned about elimination reactions, I would say this would favor elimination. But because we haven't talked about eliminations yet, if you had to pick between SN1 and SN2, this would have to go SN1. But actually, I think this would be an E2 reaction. So I'm not going to draw it out. But if it was going to go by an SN1, the leaving group would leave. You'd get a positive charge, and then the nucleophile would attack. And so you'd get alcohol right there, and your product would be like this. Okay, so then the next one, if you have a strong SN2, this is a primary leaving group, so that's good. It'll attack like this, and it's not a chiral center, so we don't have to worry about stereochemistry. Oh, technically neither of these were chiral centers either. Oh well, it's good practice. And then this one, okay, so this is SN1, so it would favor weak, but you can't have a primary leaving group on an SN1, that won't work. So this would actually go by, I think, SN2. And so it would be, just a methyl group. So just that with a hydrogen positively charged. And then you get deprotonation. So you would get this. Hopefully that's helpful to you as you work through your SN1, SN2 homework and your Chapter 6 homework. And good luck studying.